Okay, so this is a short video on the trapezium rule, mainly just teach me how to use the camera more than anything else, but hopefully it will give you some useful mathematics. First of all, what the hell is a trapezium rule to get on with? Trapezium rule is a numerical method of working out the area under a curve. Of course, you can usually directly integrate with a lot of the mathematics you do, but to be fair, there's a lot of integrals that you may just not have the skill to integrate, or to be fair, you might just get asked the question in the exam. So let's just deal with it. Right, so what have we got here? We've got this huge honking great formula right at the top of the whiteboard, which basically says if you integrating something between two numbers can be approximated by, and that should really say approximated, not equal, half h, and then there's a whole bunch of y's, y0 plus yn plus two loads of y1 all the way to yn minus 1. Okay, how does that work? Well, the idea is a lot more simple than the algebra makes out. So let's talk about that for just a second. The example we're going to use is the integral between 2 and 0 of x squared. And you'll see that all this algebra actually turns into something quite simple. So you've got integral between 2 and 0 of x squared, and I've done a little sketch for you. And what I've done is basically gone back to GCSE and said, well, look, you can approximate the area under a curve by a bunch of trapezia. And all I'm going to do, the only difference between what I'm doing here and what you did at GCSE is that we're going to use a formula rather than draw things by hand, because as you know, a lot of your diagrams are not drawn to scale, so it won't work. So here's how it works. I've decided to split my B, but they'll generally tell you exactly how many strips to do. So don't stress too much about that. You've also got numbers underneath them. And you see, because I've split from 0 to 2 into 4 strips, I've got 0, 0.5, 1, 1.5, and 2. And I've labeled underneath them x0, x1, x2, x3, x4, and that's what they are. Now you might have said, well, look, Vijay, your formula says a half h. Well, first of all, what is the h? Well, the h is merely the difference, basically the width of the strips, probably the easiest way of describing it. From 0 to 0.5, 0.5 to 1, 1.5, they're all 0.5. Yeah, the width of the strips are just 0.5, so therefore h is 0.5, and you see that I've written that on the whiteboard. Then the formula says y's, and I'm talking about x's. So how do these things kind of interact? Well, it's really simple. If you substitute your x0 into the thing that is inside the integral sign, so here x squared, you get the y0. So for example, 0 is x0, so 0 squared would be y0. So x0 is y0, they're both 0. But it doesn't have to be this way. So if you had x, let's say x1 is 0.5. So y1 will be 0.5 squared, which is 0.25. See how that works? And all the formula says is you take a half, you multiply it by what should really, we can just call it the class width or the width of the trapezium or whatever, right? So half times 0.5, and all of that is going to times a huge bracket. And inside the bracket is just, all you've got to remember is that the first and the last values, the y0 and the y4, get added to each other. And then those guys get added to two lots of everything else. So it's going to go first value, last value, plus two lots of all the other values. And that huge bracket gets multiplied by a half times whatever the width of the trapezium is. And that actually isn't that difficult. Yeah, so you can see I've got half, because it is a half, 0.5, because that's what the width of the bar is. And then your bracket's got the first one, y0, and then you've got y4, which happens to be 4. And then 2 times all the other ones, so 0.5 squared, 1 squared, and 1.5 squared are the other three, the three in the middle. I hope that makes some sort of sense to you. If it doesn't, I'd recommend recapping. I've got the camera quite steady, but maybe I think I probably will have to kind of if I'm dealing with questions, try not to sit so still. I don't know what you think of this. Put comments, abuse, whatever. Do they compare to the other videos? I'm literally wearing a camera. That's why the camera is what it is. Bye. Let's see how this turned out. See you later.